Let us continue our discussion. In the previous lecture, I have discussed about types of programming languages, that is low level and high level languages. Now let us explore about high level languages further. Now one thing you should know about the high level languages are either compiler based or interpreter based or hybrid. What does it mean? See, high level languages are more like English. They are more like English. We write the programs using high level language. Suppose this is our program file. Now this program is in high level language. Machine cannot understand that. So this high level language program code should be translated into machine language code. So who does the translation? So translation is done either by compiler or interpreter. So it's done either by compiler or interpreter. There are two methods of translation. One method is compiler and another one is interpreter. So once again, I am telling you, when you write a program, a source code or a program in English-like language, like C, C++, Java, Python, whatever the language that you are using, that has to be translated into machine language, and it is done either by compiler or interpreter. So some programming languages uses only compiler. Some programming languages uses only interpreter, and some uses both. So that's how I am saying that some programming languages are compiler based and some are interpreter based, and some are hybrid languages which uses both compiler and interpreter. So the nature of the language itself will be compiler based. It's not that suppose I say that C language is compiler based. So it cannot be interpreter based also. It is by birth, it is compiler based only. So a language by nature, it's compiler based or interpreter or hybrid. So let us see what are the languages which comes under compiler based and interpreter based and hybrid. See the languages like C, C++ and some more languages that are old languages. These are compiler based languages. So when you write a C language program, compiler will translate into machine language code. Now interpreter based languages. Interpreter based languages are PHP, that is used for web programming, and JavaScript is also useful for web programming. These are interpreter based languages. There are a few more languages. These are the known ones, so I have listed only two. Now if you talk about hybrid, means some languages which uses both compiler as well as interpreter. In this comes Python and Java and C#, or I should say .NET languages. These languages comes under hybrid. They have both compiler as well as interpreter. So that's it. So what we have to do now is we have to learn what does it mean by compiler and what does it mean by interpreter, how they are different from one another, and also how this hybrid are different from these two. So let us know these differences. Okay, so in this way you will be learning about almost all the other languages also, not just Python. You are also comparing the other languages with Python. So when you learn about hybrid, you are learning about Python. So let us start with compiler versus interpreter. Yeah, the topic is compiler versus interpreter. So first of all, I'll talk about compiler, then I will talk about interpreter. See, let us take an example. C language is a compiler based language. Suppose you have written a program using C language. The program name is program.c file. It's a source code file. Source code is in C language. So it's a program code. Then this cannot be understood by the machine. It cannot be understood by the machine. So we use a compiler which will translate this C language source code program into machine code, and it generates a new file that is called as exe file, executable file. So this contains a machine code. Now this program, this machine code program can be directly understood by the machine and we can run it on the machine. So we use compiler. Compiler will convert this source code into machine code. So translation is done. So it's simple. Then what does it mean by interpreter? That also does the translation. Anyway, we'll learn about it later. Let us focus on compiler. Now listen to the points, the important points. Compiler takes the complete source program and generates complete machine code program. It takes a file and it gives a new file that contains a complete machine code. This is first point. Second point, if there are no errors in your program, then only this translation is done into machine code. This is the second point. Third point is, how many times translation is done? Only one time. Translation is done, we have the machine code. Now it's ready to execute. Third point is what? Translation is done only once. Whenever I am running it on the machine, which code I will be running? I will be running machine code only. Do I need the source code? No. Do I need the compiler? No. So how many times compiler was required? Only one time for translating this source code into machine code. And we run this machine code as many times as you want. You run it thousands of times on the machine, it executes. No translation is required. This is how compiler works. It is just like, suppose you have a letter in Chinese language and you want to translate in English. So this is a Chinese letter and this is converted into English letter. So this is one letter, a piece of paper, and this another piece of paper, or this is piece of file and another file is generated. This is how the compiler works. So the translation in compiler is done only once and it is done upon the whole program. Now let us move on to interpreter. Now let us talk about interpreter. See, let us take an example of JavaScript. JavaScript is a interpreter based language. So this is a source code of a JavaScript. Now when you want to run it on the machine cannot understand JavaScript. It has to be translated. Who does the translation? Interpreter does the translation. Now for running it on the machine, it requires to be converted to machine code. So will the interpreter generate a separate file for machine code? No, it will not generate separate machine code file. Then what? How it will do? So listen, if these are the lines of JavaScript code, the interpreter will translate one line into machine code. It will generate the machine code just for one line and also get it executed that time only. Then second line, translate into machine code, get it executed. Next line, convert into machine code, executed. Each line it will take and convert into machine code and also it will get executed. So this is how interpreter work. See, the compiler was not executing it. Compiler was giving complete machine code. You execute whenever you want, but interpreter will directly execute it on the machine. That's what the difference is. So see, suppose you have a letter in Chinese language and somebody is reading it out and translating it out in English for you. That's it. And he's not preparing a separate letter for you. He is just reading and translating it to you. It's just like that. So no new file is created. That's the difference. Two things. One is interpreter will convert each line into machine code and getting executed, and separate file is not generated. These are the 2 points I told you. Now third important point, whenever I want to run this JavaScript program, do I need the interpreter? Yes. So every time when I run the program, will the translation is done? Yes. Every time translation is done. So tell me, who is better? Compiler where the translation is done only once, only one time. This is better, or interpreter where the translation is done for every time whenever you are executing, translation is done? Who is better? Compiler is better. So that's why we say mostly compiler based languages are faster than interpreter based languages. This is the reason we say compiler based languages are better. So we say C++ are more powerful than Java and Python. That is the reason we say. So nowadays we have the very fast machines, so that performance doesn't make much difference for us now because our machines are much faster. That's why nowadays we prefer using interpreted languages. That is the reason. Even though if you closely compare them, compiler based languages are faster, but interpreter languages are more flexible. They provide the runtime environment. So what does it mean? Let me tell you that. So if you take JavaScript, you may be having a little bit idea because you are accessing internet from long time where this JavaScript runs. Yes, it runs inside the browser. So who is the interpreter for JavaScript? Browser is the interpreter. So what browser is providing? It provides a runtime environment. So JavaScript can comfortably run inside the browser within the context of browser, or browser provides a cradle for JavaScript. So your JavaScript programs can smoothly run inside the browser runtime environment. So the interpreter languages are more easy to write and run because they run inside the runtime environment, which is more comfortable for the programmer to develop such programs by taking the support of runtime environment. The point I have to tell you once again that interpreted languages, they are a little bit slow based on the compared to compiler based languages, because in interpreter based languages every time translation is done, program is translated into machine code and executed. So we say it is done line by line. Sometimes the entire code is converted also, but always the translation is done. That's the important thing. Now one more thing, nowadays we have made the interpreters little bit faster by introducing something called as JIT compiler, just in time compiler. Nowadays, interpreters are having this one, just-in-time compiler. So it will not translate every line by line into machine code. It will convert entire program into machine code, then execute. But every time when you run, the translation is done, conversion to machine code is done. So this is little time taking only, but by using of just-in-time compiler, instead of doing line by line, it does at once. So it is little bit faster. So that's it. I have explained you what the difference between compiler and interpreter. So why finish compiler, interpreter? Now I have to talk about hybrid. That I will do it in the next lecture. We will talk about hybrid languages. So there you will understand how Python as well as Java as well as C#.NET, these languages works and in what way they are beneficial. I will show you that one. So that's all in this lecture. Once we finish these little bit concepts and get to know a little bit about Python, we can start learning Python. Okay, so I have to cover a few more topics in this section. So that's all in this lecture.